In today's lab, we're going to simulate radioactive decay. So when a radioactive material decays, the nuclei present in the material transition into other isotopes, and in the process release various forms of radiation. The number of nuclei present in the material at any one time decay exponentially, and can be modeled by the equation n equals n naught times e to the negative lambda t, where n is the number of nuclei present, n naught is the initial number of nuclei, e is the natural base, lambda is the decay constant, or the probability of decay within some time frame, and then t is time. Then we have the half-life, which is the time it takes for half of the nuclei to decay. And if we solve the previous equation for time and set the number of nuclei n equal to half of n naught, or half of the initial number of nuclei, then the time, which is the half-life, is equal to the natural log of 2 divided by the decay constant lambda. So for this lab, we're going to do two simulations. First, we have a coin toss simulation, where the number of heads represents the number of nuclei. And then second, we're going to use a computer simulation for carbon-14. And because there are two simulations, I would recommend that if you're working with a lab partner, one of you take one simulation and the other takes the other simulation. For the coin toss simulation, we need 100 coins. I've got pennies here. And if you took the first semester labs with us, then you should have 100 pennies as part of your lab kit. First, you should count the coins to make sure you have exactly 100. I've already done that with mine. And then you need some sort of a container to put them in. It could be a food storage container, or a cup, or a box, or a bucket, whatever. I'm going to use this bag. It just needs to be something that you can put the coins in, shake them up, and then dump them out. Before we do that, let's record the trial number and the number of coins that we start with. So the initial trial is going to be 0, and then the number of coins is 100. Now it's time to shake the coins. And to make this work with a bag, I'm going to open it up so I can get some air in there. That will make it a little larger inside and make it easier to shake them. Once you dump them out, we need to remove all the tails and then count the remaining heads. And in case you're not familiar with heads and tails, heads is the side of the coin with the head on it, and then tails is the other side. So here I have all the tails, and then here are the heads. So the tails, we're going to remove those, just push them off to the side, and then count the number of heads that you have remaining. So it looks like I have 44 heads remaining, and I just need to put down trial 1 and 44 coins. Now we're going to repeat this process with these 44 coins and continue like that until we've done it 6 times, or until we have 4 or fewer heads remaining. At this point, I'm going to stop because I only have 4 coins remaining. I did expect it to take about 6 trials to get to this point, and in my case it only took 4. That does probably mean that my error will be a little bit higher, but it's an experiment. We expect some error, so that's fine. Anyway, that's it for the coin toss simulation, so just record your trial numbers and the number of heads remaining. The trial number is analogous to time, and then the number of heads is like the number of nuclei. Now we're going to do the computer simulation for carbon-14, and I would recommend that you do this on a desktop or laptop computer. It may work on some mobile devices, tablets and phones, but I can't guarantee that it's going to work as well. So if you have a computer, try to do it on that. Now there are 2 different versions of this, an online version and a desktop version. I would recommend that you start with the online version. Just run it in your web browser and see if it works. If it doesn't, you could try it in a different browser. And then if you really want to, you could try the desktop version, but I think for most of you, the easiest way will be to run it online. We've got links to both of them in the lab write-up, so just click on the appropriate link and let's get started. When you first open the simulation, it should look like this. Or if you've already run it, then you can click Reset All to reset it back to the beginning. Then on the right, make sure you select carbon-14 and then pause the simulation. Then here we're going to add 100 atoms, so click Add 10 10 times. Then on paper, you need to record the initial time, 0 years, and the initial number of nuclei, which is 100. Now we need to advance the simulation, and we're going to do that by clicking the step button. However, the step button only increases by 150 years at a time, and that's a very short time interval on the range of this timeline. You can see the half-life is over 5,000 years, and then we've got up to 10,000, 15,000 years and beyond. So we need a much larger time interval than 150 years. If we just do 150, there's a lot of data points to collect, and it will take a long time to do that. So instead, we're going to click the step button 10 times in a row, and this will advance it by 1,500 years at a time. Each time you click the step button, make sure that it actually advances. It doesn't tell us the time otherwise, so the only way to keep track of the time is by knowing exactly how many times we've clicked that button. So I'm going to click this 10 times and then record the number of carbon-14 nuclei remaining. There was a bit of a delay on that first click, so make sure you watch for that. Alright, so that was 10 times, which means our time is now 1,500 years, and then the number of nuclei remaining is 80. You can see that there on the screen. It says number carbon-14 right there. That's the number you want to record. Do not record the nitrogen number here, okay? This is something else. We're not using it. Only look at the carbon-14 right there. Now we'll click step 10 times again, and we'll advance by another 1,500 years. Now the time will be 3,000 years, and the number of nuclei remaining is 66. So just continue this process. You'll advance by 1,500 year increments each time, record the time in years and the number of carbon-14 nuclei, and you'll keep going until you get down to around 10 carbon-14 nuclei remaining. So I've gotten down to 10 carbon-14 nuclei remaining, and for me that was at 19,500 years. You might find that it's at a different number of years, but it should be around that number. That's it for the carbon-14 simulation, but now we're going to take a quick look at the dating game. So if we click over here on the dating game tab, you'll see that we have some different geologic layers with objects buried in those layers, and then we have this probe. And we can move the probe around and hover it over these objects, and it will tell us percent of carbon-14 that we have in that object. And we can try it out here. Looks like we've got a bone and then some sort of animal skull. This one is a cup, and here's a human skull, and we've got a dead tree. So let's test it out on this bone here. If I hover over the bone, it lets me estimate the age of the bone. Up here we have 83.9% carbon-14. And we can drag the slider on this graph until we find 83.9%, or something pretty close. So there's 83.7, 84.1, I think that's the closest. So let's say 1,420 years. And it looks like it liked it, so that was a good estimate. Now we can try to go down to some of these other objects, like we've got a fish fossil, or we've got, what is this, a dinosaur skull. This one looks like some sort of fossil thing, a trilobite. And if you look at the rocks, it's the same thing. So all of these ones down in the lower levels have a 0% for carbon-14. However, we can switch it to uranium-238. And it looks like the trilobite is still 0%. But let's check the rocks. So the rock here, we've got 97.9%, or this rock, 96%. Here we've got 89.4%. So let's try to estimate the age of this rock. 89.4% of uranium-238, and then just grab the slider and drag it over until we find 89.4%. That's pretty close, 89.1%. And at least according to this dating method, it says 731.05 million years. 731, this is years, so I'm going to have to do 0, 5, 0, and then 3 more zeros. And it looks like it liked that estimate. So try this out for yourself, and while you're doing that, think about this question. Why is carbon-14 dating appropriate for once-living objects, while uranium-238 is more appropriate for rocks? I'm not going to answer that right now, but I want you to think about it while you're doing this exercise. And that's it. So make sure to read your instructions. They will have more information than what is shared in the video. And good luck on your experiment.